All right, welcome. Welcome to reInvent 2018. It's kind of just kicking off the whole week of activities, and welcome to the Global Partner Summit. Really excited to be here. Today's session is scaling and automating DevOps with CloudBees and Spot instances. It was interesting. I actually renamed this segment a couple of weeks ago when I submitted my deck. And a lot of that, I renamed it to DevOps with Friends. And a big reason for that is that I am a partner solutions architect. And that means I spend a lot of time working with partners. So in a given day, I'll spend the vast majority of my day with partners. My family actually know the names of the partners, even though they have no idea what those partners do. My kids think Datadog is a pet or an animal shelter. I'm not sure. So I submitted it as my presentation is DevOps with Friends. And the event staff came back and said, wow, that is really super cheesy. And so we're going to go with our original naming convention. So I'm a partner solutions architect, and that means that I work with predominantly partners, but also customers on technical enablement. So what that means is kind of help them design for the platform, kind of get rolling to ensure efficiency, scalability, availability, and reliability. Kind of going through today's agenda. So just to kind of get everybody on the same path, we're going to spend the vast majority going through kind of some examples, some sample deployments, things like that. But we're going to go through some of the basics. So maybe for the first 10 minutes or so, we're just going to kind of get on the same page so that we all understand exactly where we're going with this. If you read the description of this segment, which I don't even think I did before I got here, but we're going to be looking at not just CloudBees, not just Spot instances, but also the integration of a number of AWS partners in a number of different development pipelines. So to kind of get everybody on the same boat here, we're going to go through some basics of CI/CD, some basics of AWS DevOps technology, the importance of testing, kind of important, and then just kind of going through some of our examples where we actually show how easy it is to kind of get rolling with some of these features. So kind of starting off the goals and the challenges. So I always love this quote because it kind of reflects a lot of what we really try to focus on here. And the idea is that you work on a lot of things that are what are referred to as undifferentiated heavy lifting. So when I first got started in technology, my first, I guess, real job was as a Linux systems administrator. And I had an individual that you could say was a mentor. Basically, he was the guy that was there to train me and tell me that everything I did was wrong. But really cool guy, absolutely one of the most intelligent people I've ever met. And he always said that your job as a sysadmin is to do as little as possible. And it was interesting because at the time I understood that as automate everything and make sure that your systems are as solid as possible, but always kind of pursue that ideal deployment, always pursue that ideal infrastructure design. What he actually meant was really literally do as little as possible. But fun guy, definitely great mentor. So what is this concept of CI/CD? How many, because this is the Global Partner Summit, how many of you are partners, are working with are partners of AWS, part of the partner network? Okay, all right, so vast majority it seems like. And so you're probably somewhat familiar, and if not, that's fine. But the idea here is that we want to automate as much as possible so that we can get rid of that whole undifferentiated heavy lifting. It's that idea of if you have a directory on like your desktop, I mean, how many times do you have like, final.c, final.c, really definitely going to be final.c-001. And so the idea is, let's keep that a little bit more organized and kind of automate getting that over to where we want it to. And then, the concept of what do we have? What are we going to do with it? And where is it going? It's kind of like really a 30,000 foot view here. And this is the template that we're going to be working through today. If you've ever been in a AWS DevOps presentation, this is probably the template that you're going to see the most. This goes through kind of exactly where we want to be and some of the goals that we have here. So we've got our source control, what do we have? Our build, what are we doing with it? And then all the way at the end, we've got our production environment, which is where is it going? There's a step in the middle there, which is our staging environment. And what we're trying to do, today we're going to give you some examples, but the goal is to really bridge that gap between being able to automatically push things to staging and then being able to trust your system to actually get them to production and have things turn out the way that you hope that they will turn out. Whenever we worked through these deployments, years ago, before there was really kind of a DevOps term, it was just operations. It was all just operations. Everybody sat in the NOC together. It was kumbaya. Everybody was happy. And so long before DevOps was really kind of a terminology that was kind of used, we had this idea of we're rsyncing these directories. We are manually copying things. We're kicking things off. There's one guy in the company that actually knows how to do a revision reversal. So we push to production. Oh no, something went wrong. We're able to reverse things, get them back to normal. And we had this entire group of people that would click through our web application to make sure that, as a customer, to make sure that everything worked the way that it was supposed to. And as you can imagine, that's pretty slow, but you tend to trust those people. This is where there's a little icon here. Oh, I'm going to use my red button. So we've got the approval, which is a manual process typically. What does it take to really trust your system to automatically push that to production? And so what are the opportunities here too? So, if we can get to that point where we feel like if we push something, it goes past all of our unit testing, performance testing, security testing, it will be ready for production. That's going to get our product to the customers faster. It's going to reduce maintenance and really focus on, what kind of testing does it take to really get there? But how did we used to do it? You always kind of look to the past to, predict the future, something like that. And so, what was the process? It was shell scripts. I remember, kind of working through some of these issues in the 90s. It was considered kind of a big leap just to have automated shell scripts that did this. We had CVS version control, and it was amazing because all you did was a commit, and all of a sudden, boom, it was over into your staging environment. Everything was testing. Being able to roll back. It was a pretty big concept back then. But everything was manual. So every time you went with a new project or you started at a new company, anything like that, you'd have to rewrite a lot of these shell scripts from scratch. And you had a lot of people kind of bringing all this collateral with them, which also left technical debt behind them. All of these manual processes to kind of get all this updating. And then limited testing. So seeing as this is a DevOps presentation, there's probably a lot of you that have experience using Selenium, JMeter, a ton of different tools out there. But even then, it takes a little bit of a learning curve in order to get kind of up to speed with those tools. So how do we get that done even quicker and even faster? I always loved the idea of the AWS pace of innovation. It's constantly almost doubling every year, and it kind of shows that we really subscribe to some of these models that we're pushing. And so here's kind of our mantra. So whenever you work for a company with AWS, we have our leadership principles. With CI/CD, this is kind of our pillars that we're really focusing on. So everything that we're doing should have a basis in, improved collaboration, the rapid delivery of these products and features, the reliability of the system, as well as the processes and pipelines that get that system out there. Obviously, security, pretty important. It's job zero at AWS. The ability to scale and the speed of both deployment and the application and getting those products out. So we're not actually going to be demoing CodeStar today. It's just something I wanted to do a quick call out to. When we're working on, what I hear a lot is, I'm just doing a small project, I'm just going to push it up, and I'm probably not going to have to update it. So there's really no need for a pipeline or anything, and it takes a while to deploy a pipeline. You get a lot of these little pieces of feedback, but I would encourage you to just give CodeStar a shot. It's pretty cool. I recently switched over completely to using the Cloud9 IDE. It's been a lot of fun. It comes with a dark theme. Pretty excited about that. And so all of these components are kind of built into CodeStar. So if you want to deploy, let's say, a serverless application, you have a lot of the tools already built in, a lot of those pipeline features already built in. So it just kind of gets you up to speed a little bit quicker. And so I just thought it was pretty interesting. But overall, here we have our services that we're going to be looking at today. So for version control, just for simplicity's sake, in all of the examples, we're going to be using code commit. Obviously, there's a lot of different examples. During last reInvent and reInvents previously, I would always use GitHub. But this year, you can use S3. You can use a ton of different things. Just for kind of that simplicity, we're going to stick with code commit for today. For our build, in 2 of the examples, we're actually going to be using code build before we start kind of going into Jenkins. We're also going to use a little bit of code pipeline with Jenkins, and then obviously kind of focus on a little bit of spot instances. But then third-party tooling. So, remember how I talked about how are we testing these applications to make sure that they're, kind of ready for prime time? What does that look like? It's, in order to get these tests into the system, how hard is that to configure? And that's something I'm really excited about because it is just built into a lot of these processes. And so we'll be showcasing that. And then what does production look like? So this is a placeholder here. Our production environments today are going to be Elastic Beanstalk for one, Code Deploy for another, Lambda API Gateway for another, and then ECS for our Jenkins example. And then we're using code pipeline to enable this orchestration. Once again, obviously we can use Jenkins for this approach. This is for the continuity of the examples, just to try to make things not overly complicated when we're switching between one and the other. And then, once again, my call out to CodeStar. It's pretty fun. It's super easy. When we look at a lot of the technology partners, so if you Google AWS DevOps competency, you're going to get a lot of the AWS DevOps competency partners. These are partners that I spend probably just as much time with as I do my family. And so they put together a lot of really cool solutions. I've got blog posts with, actually me and just about everybody else in my group has blog posts with just about all these partners. These are the partners that we did not highlight in the example today, and it is purely because of lack of time. There's only so much you can do in an hour. And so kind of kicking things off, the idea of deployment testing. Today we're going to be showcasing Ghost Inspector. Ghost Inspector is an AWS partner solution. They have direct integration with AWS Code Pipeline. And kind of one of the really fun things I like is probably the simplest thing that they do, which is the Chrome browser extension. If you're putting together an implementation and you want, what is the quickest way that I can get some unit tests done against my web application? Let's say I have an individual that is not technical. Like, let's say I have that person in QA that is used to just, clicking on a website, entering some information, validating forms, the typical QA type of responsibilities where you're making sure that, the blue graphic is indeed blue. How easy is it for them to be able to create a unit test, to be able to offload some of these responsibilities that have been sitting with, a lot of the DevOps individuals, the engineers, the developers. And so, Ghost Inspector really puts a lot of that simplicity into the hands of individuals that may not be as technically enabled as others in the organization. And then we're going to go through some load testing. So the examples that we'll be using today in the demos are run scope and BlazeMeter. I wanted to call out a couple of other solutions. So Micro Focus has a direct integration with AWS Code Pipeline. Also has a free trial to give it a shot. And then Locust. Locust is a fun one. So years ago, I'm doing a blog post with a company called Spotinst. And the whole point of the post was use Spot instances to be able to scale your auto-scaling groups so that you can scale to meet demand. So if you have to run 100 instances, wouldn't it make more sense to run those 100 instances on Spot instances? And so at the time that I did the blog post, I needed a load generator. At the time, the Chicago Tribune had a project that they open sourced called Bees with Machine Guns. And it's kind of been serving me for years now, and so I didn't bother to look at anything new. And the DevOps group here, probably last year, said, you should really check out Locust, and it was really great. So if you're looking for an open source tool, this is the recommendation that I got from the engineers. It deploys quite well with ECS, and it's really scalable, and really important is kind of free to use. So that's kind of a fun example. And so we'll be starting off with from the most basic examples that we can think of. So today we're setting up a web application first, and we're going to be deploying it to AWS instances. Just like whether you're running your build server or you're running your web servers or your database servers, we always want to make sure that we're running things as efficiently as possible. So if you're running a Jenkins instance and you need to, as we'll show in some of the examples, it's only around to build a couple of things. You probably don't want to be paying on-demand prices because you're paying a premium for a system that you're only using sporadically. At the same time, if you have that main orchestration server that you always want to be available, you want to make sure that you're running it as a reserved instance because it's not going anywhere. It always should be around, and you want to make sure that it's around. At the same time, there's been some new additions to EC2 Spot capability. We're going to be going through the deployment and utilization of EC2 Spot Fleet, but there's a lot of really other cool examples, like the ability to say, I want a Spot instance, and I definitely want it to be around for an hour or for a half hour, so that even if you're outbid, you don't lose access to that instance. And so for our simple example here that we're starting off with first, we're going to be using code commit as the source code. We're going to go through what the build definition looks like. Code build is going to build this one. And then we're going to be sending output artifacts at first to Elastic Beanstalk, and then we're going to be sending them in the second simple example over to code deploy to go to EC2. But just as we're using code pipeline, just as we're using code build, all of these components can be replaced out with Jenkins. It's kind of a little bit of personal preference. And so, later on in the day, half hour from now, we're going to be looking at what does that look like, to replace out these components and utilize Jenkins for these service interactions and engagements. All right, so let's see. Oh. All right, so, oh man. Didn't see that coming. So today we're working with a company called Unicorn Rentals. They are the 16th largest provider of mythical creatures in the Western US. How many people here have been to a AWS Game Day event or planning to attend AWS Game Day at reInvent? All right, we got one. We got one. All right, thank you, sir, because it would have been awkward to have zero. So I'm responsible for the AWS Game Day program, and Unicorn Rentals is the company that we use for all of our events. So in today's example, this is the Unicorn Rentals reservation lookup application. So the idea is when you rent a unicorn, you get a confirmation code. You want to be able to have a website where you plug that confirmation code in and you get the unicorn access code. So when your unicorn arrives at your house, you whisper this code in its ear and it follows you around wherever you go. So this is what we're going to be replicating throughout our examples. So starting off, how do we create this pipeline from the very beginning? So we're going to create an AWS code pipeline. Kind of fun, I decided to record this at the last minute since typically these things tend to break. So hopefully this works. So we're creating a brand new pipeline. As we kind of said, we're going to be standardizing on code commit for these examples. And I have a repository set up for each of these. So the repository for this example is DevOps Beanstalk. I'm committing everything to master, and we're going to be using CloudWatch events to kick off the build process rather than having code pipeline constantly pull code commit for this information. We're going to be using code build for the build environment, and so we're going to be creating a new code build process here. As you can see, it's built directly in. You just click on create a new one. We're just going to name it. We're going to provide some really basic information, but the instructions for how to build are actually in the repository already. So everything is going to be built using Linux it's actually a Golang binary that gets deployed. So we're going to specify Golang as the environment. There's only one option for versions. And this is not going to be a Docker container, so we're just going to create a standard Golang build environment so that it compiles the single binary and it's able to deploy to our Beanstalk environment. By default, it'll be the buildspec.yml that exists within your repository, but you can set that to whatever you want. So if you want to name it something else, just put the file name in there. Otherwise, just like Jenkins, you could put all of those run instructions directly into code build manually. Here, we're going to be deploying this example to Elastic Beanstalk. We already have our environment identified here, so we're just going to pull up what's already built in. I don't think anybody wanted to see me build a new Beanstalk environment. So our Beanstalk environment is a Unicorn app, and so boom, we create the pipeline. And so now this pipeline is created in code pipeline. As its first responsibility, it's going to go through, it's going to build everything, and just run through that pipeline to make sure that everything kind of deploys properly. So it's doing the pull from source. But what we don't have here is the actual testing components. So, kind of this follow the bouncing ball approach gives us a really basic implementation of what a pipeline should be. So now we want to add some of these test components. And so one of the things we mentioned is the fact that this is built directly into code pipeline, a lot of those partner solutions. So here, real simple, we're going to add a stage. Once again, it's almost like a follow the bouncing ball. We're going to do first that ghost inspector engagement, and that's just going to make sure that when we deploy our application, does it work? Does it work as intended? So this is going to do things like, when you pull up the website, does it contain the text that it's supposed to? When you submit values, do you get returned information like you're supposed to? And so, this is, and we're going to go through exactly how to create these tests in a second here. But what I want to highlight here is the ease of integration. So we select Ghost Inspector from a drop-down list, click on Connect, and all of our unit testing, all of our pre-created tests are now available for selection. So I've got my Unicorn Beanstalk example, click on Integrate, and then Save, and now we have that test built directly into our pipeline. And as you'll kind of see, it's kind of fun because the creation of the test is so simple with that Chrome app that this whole process to create the test of the application and get it into code pipeline, I did this with a pretty slow internet connection, but it's typically like under a minute. It's pretty impressive. I can't think of how to make it kind of any easier at this point, which is a nice change. So now we know we have our test of, does the application work at all? So we want to add another test, which is, is the performance where it's supposed to be? Killing me. There we go. So what does the performance look like? So we're using BlazeMeter. We've got that direct integration once again. We've selected just BlazeMeter from a dropdown. We predefined our BlazeMeter test, and we'll go through that in a second too. But this just shows kind of how easy it is to get this into the pipeline. It's add a stage, add a component to the stage, a few items from a dropdown, and then save. And now we've got it all added to the pipeline. We're going to release the latest batch of changes and push that all through that pipeline. Now, once this is done, it's going to update our Beanstalk environment, and we're going to have, our CI/CD pipeline. So anything that's checked into code commit is automatically going to be pushed over to Beanstalk, and then it's going to go through Ghost Inspector testing and then BlazeMeter performance testing. So that's our first super simple example, going over to Beanstalk. We're going through the same process now, except instead of deploying to Beanstalk, we're deploying to AWS Code Deploy. So the idea is we've got a few different instances that are a part of a deployment group. Once again, it's the same thing. It's a Golang application that's been compiled to a binary. And so it's just taking this application, it's pushing it over to a bunch of instances, starting it up, and getting ready for the deploy. Just as in the last example, we've got Ghost Inspector, making sure that the application actually works the way that it's supposed to. We've got BlazeMeter, making sure that the performance is where it's supposed to be. So we've got, maybe a little small to see, but we've got our appspec.yml, which is what defines how everything interacts with code deploy. So once it gets to the EC2 instance, what is it supposed to do? And then we'll go through a little bit more what the build spec looks like. So the build spec is very similar for the first two examples because it's doing the same thing. It's getting all that source code, compiling an application, and then pushing that out. In our example here, we actually just made an update, not important, but it actually changes the performance aspect of the application. So for whatever reason, the organization has decided to make the application slower to save resources, or I can't remember why. But the idea is that we just made the application slower. How does that impact the outcome of our testing? Everybody's probably familiar. We just checked in a change to our source code repository, and we're going to watch it kind of go through the process here. So it's a little bit quicker when with our integration with Code Pipeline and Code Commit, because we are using that CloudWatch events integration. So we're not waiting for the Code Pipeline to keep polling every minute or so to see if there's a change. So it should be kind of a little bit quicker. And it's going to go through this process now. Which is... There we go. So while it's going through that process, we're going to kind of look at this build spec here. So this is the definition of, in that pipeline, what is it that code build is supposed to be doing? All this is, if you're not familiar with Go, it's just downloading a bunch of libraries to this code build environment. It's running the make command so that it goes through and just compiles all this. For those not familiar with Go, the source code is compiled into a binary, and that binary can be run on like operating systems. So we're compiling for 64-bit Linux, ELF32, and so that binary should be compatible with the other Linux systems that are also, x86, ELF32. Here we have a closer look at the app spec. The key component here is that we've got a few INI files that are required to be sent along with the application. So the application has to know like where the database server is, you know, other components that are important. So we include that in the app spec, as well as the build file to make sure that it's included in the source code archive and that it gets copied over to all of these instances once we deploy it to code deploy. As we're going through, we see that the test for Ghost Inspector has passed, and we have our website. So we're going to look at what is it that the website should do. So we get to our reservations lookup page, and we want to be able to enter a reservation here and then get the results back. You'll notice that something that should be pretty instantaneous actually takes a second. So that's something we want to keep an eye on. Is that performance where it's supposed to be? I think I sped it up because it actually takes 5 seconds to return this value. And so that's technically a little bit slow. Is that something that our pipeline is going to end up coming across? So here we're gonna showcase the Chrome app for Ghost Inspector. I thought this was pretty nifty. It's really straightforward. So you go to plugins, you install the Ghost Inspector app. You obviously log into Ghost Inspector. But now once you've done that, you go to your website, and we're going to start recording what it is that we're doing. So at the very top, we click on Ghost Inspector, we click on Start Recording, and we're going to be creating a new test. And once again, Ghost Inspector is just, does this work or does it not work the way that we want it to. So the first test that we did is, does the website come up, right? Now we make an assertion. Does the website contain the text that we want it to? Now we record actually clicking on a link. So it records, it'll click on that link, and now if that link works and a new page comes up, does it contain the text associated there? Now we're going to enter our confirmation number. So this is our sample that we're using. This is a production Unicorn customer. So I guess technically it's Unicorn Rentals production data. And so we've entered this customer's confirmation number, and we always, when we're looking up that customer, we always want it to contain that reservation code. So in under 30 seconds, we now have a full test that ensures that the Unicorn Rentals website comes up. Ghost Inspector pulls a screenshot down as well, so that every time it runs through this process, you can actually have a little screenshot that shows you, oh, it also looks good too. You could do a lot of CSS testing as well, but this is the very basic. So this is the question, as we said, does this work at all? So we've done the integration, we've pushed a change through, and we see that Ghost Inspector has come up as a success from that test that we created in our Chrome application. Previously, I guess we're running another one now. Here's the test definition, and it goes through exactly what we anticipated it'll go through. It enters that reservation number, it double checks that the website responds at all, obviously. It does that simulated clicking on those environments, and it makes sure that all that text is there. So that confirmation code that we entered as our example is the confirmation code that it pulled up. And then super important is that Unicorn access code that comes up. That's the most critical piece to make sure that that never changes. So this customer should always get that value. It's pretty nice. We have a static value that we can test against and make sure that the application is definitely working. And then we see the screenshot of what the system sees on the right there, and that's with the full CSS and JavaScript rendering. This website is actually it's Bootstrap, so it's nice to actually have that visual representation here. But what about that performance testing? we see that we've only got 5 virtual users that BlazeMeter is testing for. So out of the 5 users that are being tested to hit this application, we've got a performance time, an average response time of 24 seconds. That means that when 5 people hit this website at the same time, it's taking 25 seconds in order to get a response. Interestingly, the leadership at Unicorn Rentals is actually okay with this response rate as long as it's under 30 seconds. And so this test is actually considered passing. We'll see a test that fails, but their magic number is 30 seconds. But as we see from the performance metrics over here, we've got an average response time of 18 seconds initially. We've got some failures, but kind of the fun part here is the overview that you get and a lot of the visual representation of this information as it goes through. So we kind of looked at how, kind of how simple it is to get that integration going with BlazeMeter and our pipeline. And now this information, this data, this report is just made available quite simply, with minimal, with minimal configuration, minimal implementation. We also, here's some JMeter information that might look really familiar to some people in this group. But our original test configuration, this is where we identify what are those success features. What denotes a success versus a failure here. And so some of those values that we set are the maximum response time should not be over 30 seconds. Here we see that it is 22 seconds as our response time, our maximum response time. You should not have any errors. Also, the number of errors should not have, I think it's less than 2 or less than 5%, something like that. But this is how we identify, how we create this test. So BlazeMeter has a bunch of different ways that you can configure a test. You can upload a script, you can upload JMeter, you can upload Selenium scripts, do a bunch of different things to get the scripts updated, or you can use their web interface to define what the test looks like. And this is where we set those failure and success parameters. And so as we saw from this example, we give it a URL, and we're just posting some data over to the API, and that's the test that's taking place. So we have our test defined in BlazeMeter. This one's still running in our current pipeline, but the test is defined so that when it runs through Code Pipeline, it hits that test definition, and Code Pipeline knows exactly what it's supposed to be testing. So after all this is done, we'll have a success from Ghost Inspector, which says that the application's working, and we'll have a success from BlazeMeter that says not only is it working, but it's within pseudo-acceptable performance parameters. And so we went through, so that's the simplest examples we could think of is you've got an application, a single binary file, a couple of configuration files, and you're deploying that to EC2 instances. There's no containerization. It's just we're taking an application, running it on instances, and we're automating that deployment. So how do we look at some of the other opportunities here? So the next one is how do we build that exact same application, but we're going to do it serverless, right? So kind of going through some of the services we're going to be using. Technically these are the serverless services, but we're going to be using Lambda, S3. Interestingly, we're not going to be using Dynamo. It's a long story. But we've got our serverless application, which is the idea of infrastructure as code. Everything that's going to be used for this serverless implementation of the application is defined in CloudFormation, as well as some random zip files that we're going to be digging through. And this is what the overview looks like. So we've got CloudFront sitting in front, API Gateway, which is handling our HTTP endpoint. We've got some static content in S3. Lambda is going to be doing the dynamic execution. And then interestingly, 2 weeks ago, the application was written in Dynamo. As I said, we work a lot with our partners. One of my partners asked me to do some performance testing with Lambda and VPC. So in order to do that, kind of two birds, one stone, I switched it over to MariaDB/MySQL with VPC. So the application is now Lambda, connecting to a MySQL, compatible server using VPC. Maybe. All right, so one of the first things we'll notice is a little bit about the performance aspect. This application, it was a single binary previously. It is now run in serverless. Because we had to refactor the entire, because Unicorn Rentals had to refactor the entire application for serverless, they actually changed some of the performance metrics associated with it. So it's much faster than it used to be in EC2, but that's entirely because they got a new team that came in and redid the source code. So we've got, once again, we've got our Ghost Inspector implementation that is going to be doing our testing. We've run through how it is that we engage with Ghost Inspector. We also have BlazeMeter that's going through and doing a lot of the performance metrics as well. That's actually, so sorry about that, that's actually out of order. Yeah, sorry about that, did that a little bit out of order. All right, so going through, what does it look like to be serverless here? We've got, so we're using API Gateway in order to create this API endpoint. So we've got our static content that is being hosted in S3. We're using jQuery in order to query our API endpoint. And we're using VPC with Lambda to be able to get the data out of a MySQL compatible server. So the first thing that we're going to do is we need to create our Lambda function. We're using the serverless application model here. So it's all wrapped in a CloudFormation template and then dynamically updated with the serverless application model. So as you can probably expect, we want to create test cases with each of these steps. So we've got API Gateway with a built-in test. We've got Lambda with a built-in test, so that we can ensure functionality on every step here. We've got when we're looking at the serverless application model, we're going to get the definition for our API Gateway endpoints as Swagger, and so that's part of that dynamic updating as this is pushed straight through. The Swagger file. By default, you probably want to, even when you copy it over to your pipeline, you probably want to dig through it a little bit more to update things like cores or any other details that are kind of important to your implementation. So we've got our API defined as /lookup. We're expecting a post, since that's the only method that is returning information. And so the build pipeline looks a little bit different, as does the build spec. We're still doing that make, so we decided to keep it as Golang, only now we're building Golang specifically for Lambda. So it took a little bit of refactoring. As part of this build process now, since everything is serverless, we're copying some assets over to S3 because there might be some HTML updates where code build will create a copy of the build archive, but as you can see, I always tend to keep an extra version laying around, which is why lookup.zip is copied over to a static location in addition to what code build creates. That's a versioned destination so that I could always see, I always have a static link of where my current code base is located. We've got the important part is that CloudFormation update segment. So what happens is you have this idea of a CloudFormation sort of overall template, and then the SAM update that's applied to it. So we have a template that says these are the Lambda functions that are needed, here's the Lambda permissions that are needed, and then as code build goes through and creates these new iterations of the application, it'll actually update that process so that when you create a change set, so in CloudFormation, we have our stack already running. The stack never stops running, it just gets updated. That's done with a change set. Here we have, the difference here is run scope. So run scope is what we're using for our API monitoring. So in the previous examples, everything was done as a single standalone application, single binary. Here we have our API endpoint with HTML separate via static content that then does the pull as needed from that dynamic endpoint. So run scope is just purely testing our API gateway implementation. So run scope will do a post against this during the deployment process. It'll just send JSON data directly to our API gateway endpoint, and it expects a specific JSON result back. With our HTML file that's being hosted statically, this is a jQuery implementation. So that's something that you're going to see for serverless content. You're going to look at a lot at like Angular, React, standard jQuery. But it is this separation between that which is static content and that which is the API. So seeing as we're looking at API, this is a curl representation of pretty much exactly what run scope is going to be doing. So it's just doing a post to our API gateway endpoint, and that is the JSON data that should be returned. So if we mucked anything up during the build, we obviously want this to fail. If it fails, run scope will pick that up. And it's the same thing as adding Ghost Inspector to the process. It's the same thing as adding BlazeMeter to the process. Run scope is a drop-down option when we say what test are we going to implement here. So here's some of the details associated with run scope. Have a little bit of performance information, but what we're looking at here is we're using BlazeMeter as the emphasis for our performance testing. What we care about with run scope is, does it work and does it resolve in an acceptable amount of time? So we're looking at error rate, very similar to what we're looking at with Ghost Inspector. We're looking at error rate, does it work, and does it work in an acceptable amount of time? So just like before, we're doing a build with code build. The difference here is that when we deploy this application, this is doing a deploy directly to CloudFormation. So it does a call that says, I have an update for everything in CloudFormation. So our API gateway, our Lambda, everything is in CloudFormation right now. We have an update to do. So a change set is created. So there's actually two different steps here. The first is that the change set is submitted to CloudFormation, and the second one is that the change set is executed in CloudFormation. And kind of this is where you get that divide between, do we automate everything, or do we have a manual process that says, I accept the change? So, we've automated everything here, which is that execute change set. In a typical workflow where you don't want to automate that final leg to production, you would make that a manual step where your QA staff says, okay, I accept this change. I don't think it's going to break anything. Execute change set. And then that's how you get that final leg as it goes to production. final example here. I think we need to see the slide deck again. So we now have our application running in the serverless environment. We've seen the example of checking that the application is functioning with run scope. So what does this look like with Jenkins, and how are we doing this entire build environment utilizing Spot instances? So we have the same application. Once again, this is a Golang application in this example. We're building it in Jenkins. We're deploying it to Docker. So we're having to build this Docker container, store this Docker container somewhere, and then instruct ECS that's actually orchestrating the Docker container that it's ready for update and it should be updated. We've got, once again, we're doing some checking here. We're standardizing on Ghost Inspector just to make sure that the application runs as anticipated. So here we have our Jenkins instance. If you'll notice on the bottom left, we've got some executors, which are our Spot instances that are being run with this. Jenkins has a Spot Fleet module plugin that we're using, and here we've selected a fleet within a region. We're defining this fleet according to what are the requirements of our application, what are the requirements for our build. For this specific build, we're using T-series instances because this is a pretty quick build. You want to make sure that you use the instance types that kind of really reflect what you're using. But the fun part here is that you don't have to say, oh, I'm going to use a T2 micro, I'm going to use a T1 micro. You can say, I want to use this class of instances, just whatever's cheapest, and let Spot Fleet figure that out. You could say, maybe I want to use, maybe I want to expand that to M3s, M4s, whatever it looks like. Let Spot Fleet do those calculations. And you just say, I just want a fleet that meets these requirements. That fleet's always available. You don't know exactly what instance is available, but that fleet's always available. So whatever's assigned to that fleet starts up, it attaches to your Jenkins instance, and is run as an executor for that instance. Here we have, so we've just, in our example, we've just made an update to the task definition. So we've updated the application. The application, kicks off a code commit update, which requires the entire process to rebuild this container because we built everything as a single static piece of content in that container. And so Jenkins creates our new container. It uploads it to AWS ECR. You can see we have a version tag here. And when we refresh, you'll see that there's a new task definition that goes from 11 to 12. And so as this process goes, it creates a new container, uploads it to ECR, creates a new task definition, and then tells ECS that there's a new task definition. So you have to update all of the current tasks that are running and get that new version out there and deployed. Here in our task definition, you'll notice that there's a build number of dynamic parameter at the very end, and that's where we identify the build number from Jenkins. And just to make it a little bit more easier to read in the world, we tag it with a version number so that we can see that this is version 28, 29, that type of thing. Here's our Docker configuration. Super simple. It's a single binary with some configuration files associated with it. And then for our production environment, we also included the app spec, but that was because I was also going to be deploying to code deploy. So once again, we've got our Jenkins implementation. It is actually going to be building all of this and deploying all this via those Spot instances that are dynamically associated with the Jenkins server. If, let's say that we are not bidding enough in our Spot fleet where we would lose our instance, what would happen is that instance would drop off. Something that does meet our pricing guidelines, the cheapest thing out of all of those different EC2 instance categories would be associated, and then that would become available for building. One of the questions that we get is, what if, I'm in the middle of building, I've got a 4-hour build process. I don't want Spot Fleet cycling out those specific instances, just to give me something cheaper. I want that one instance that started the build. And that's actually another feature of Spot where you can do guaranteed time on instances. So, you would then say that for each of these Spot instances that I'm starting up, I want this available for X amount of time so that, it wouldn't go anywhere. In our example, this is a really quick deployment. This only takes 2 minutes to build. So, if it fails, just let it do it again on a different instance. Here we have our build instructions. We're using the Jenkins Golang plugin. We've got our commands here, real simple, pretty much a make all. Download some libraries. We're building our container with the Jenkins Docker plugin. We're identifying that build number. And then we're doing the execution. We've got our build steps there in the execution. And these are just some instructions that say, create a new task definition for each of these, and then update ECS with that associated task definition. So as we do an update to any of this, whether it's an application code update, whether it's an HTML update, that content is constantly rebuilt and constantly pushed out to ECS. And a really fun part is we can really easily expand this to do blue-green deployments, where maybe it only updates to half and there's an association with a staging URL to those half. If there's something that does go wrong that you don't see, you can easily revert back. You could do this idea of 50%, 25% deployment strategies. There's a lot of different configuration options associated with that. And then, the overall view here for that one is, we've got code commit, creating a change. We're having Docker. We're having Jenkins orchestrate everything, push to ECR, and then over to ECS. And that's it. I would encourage you to please fill out your surveys. Then in our department, we have a little competition. Whoever does the worst on the surveys has to walk home. And so Seattle's pretty far. So I'd like not to do the worst, but that's all right. I got a new pair of shoes, pretty excited. Also, as I said, kind of doing a little bit of a promo for game day, so I've got stickers. So if you guys want to hang out for just a second here while I hand out stickers, I'd appreciate it, and thank you very much.